Unit 3, Part 2. Different types of plots in Matplotlib. Matplotlib provides a wide variety of plot types that can be used to visualize data in different ways depending on the requirement. For example, line graphs are used for showing trends over time, while bar chart helps compare values across categories. Histograms are used to understand data distribution, and scatter plots show relationships between variables. Pie charts represent proportions, while stem plots are useful for discrete data. Stack plots help visualize cumulative data, and box plots are useful for identifying spreads and outliers. Error plots show variability in data, while in plots combine distribution and density information. And 3D plots allow visualization of data across 3 dimensions. Each plot type serves a specific purpose and helps in better understanding and analysis of data. Creating bars. This code demonstrates how to create a simple bar chart using Matplotlib. First, the required libraries are imported and the data is defined using NumPy arrays where X represents the categories such as A, B, C and D and Y represents their corresponding values. The plt.bar function is then used to create vertical bars for each category with the height of each bar determined by the values in the Y array. This type of visualization is useful for comparing different categories easily. Finally, plt.show is used to display the bar chart. This example shows how to create horizontal bar charts and customize their colors in Matplotlib. Instead of using the bar function for vertical bars, an barh function is used to display the bars horizontally, where the categories are placed on the y-axis and the values extend along the x-axis. This type of chart is useful when category names are long or when we want a different visual representation. Additionally, the color of the bars can be customized using the color parameter in both bar and barh functions. For example, setting color equal to red will display all bars in red. These options help in improving the visual appearance and clarity of the chart. This example explains how to control the thickness of bars in both vertical and horizontal bar charts in Matplotlib. In a vertical bar chart, the width parameter is the bar function. In the bar function is used to adjust how wide each bar appears. By default, the width is 0.8, but it can be reduced, for example, to 0.1 to create thinner bars. Similarly, for horizontal bar charts created using barh, the height parameter controls the thickness of the bars. Reducing the height value makes the bars thinner in vertical direction. These adjustments are useful when customizing the appearance of the chart or when displaying multiple bars in limited space to improve clarity. A histogram. Histogram is a type of graph used to represent the frequency distribution of numerical data. It shows how data values are distributed across different intervals or ranges known as bins. Each bar in the histogram represents the number of observations that fall within a particular interval. This makes it easy to understand the overall distribution of the data, such as where most values are concentrated, whether the data is spread out, or if there are any patterns or skewness. Histograms are especially useful for analyzing continuous data and gaining insights into this distribution. Create histogram. This code demonstrates how to create a histogram using Matplotlib. First, the required libraries are imported, including NumPy and Matplotlib. The data is then generated using np.random.normal, which creates a set of values that follow a normal distribution with a specified mean, standard deviation, and number of data points. The plt.hist function is used to create the histogram by grouping the data into intervals and counting how many values fall into each range. This helps visualize the distribution of the data clearly. Finally, plt.show is used to display the histogram. Creating pie charts. This example shows how to create a pie chart using matplotlib. The pie function is used to divide data into different segments where each value in the array represents a portion of the whole. Each segment, also called as wedge, corresponds to a value, and its size is determined by comparing that value with the total sum of all the values. By default, the first segment starts from the x-axis and is drawn in a counterclockwise direction. Pie charts are useful for showing proportions or percentages in a dataset. Finally, the show function is used to display the chart. This code demonstrates how to create a simple pie chart with labels using matplotlib. First, the required libraries are imported and the data values are defined in an array where each value represents a portion of the whole. A separate list of labels is also created to name each segment, such as apples, bananas, cherries, and dates. The plt.py function is then used to generate the pie chart, where the label parameter assigns names to each wedge. This makes it easier to understand what each portion represents. Finally, plt.show is used to display the chart. This type of visualization is useful for showing how different categories contribute to a total. Start angle. This example shows how to control the starting portion of a pie chart using the start angle parameter in matplotlib. By default, the first wedge of the pie chart starts from the x-axis at 0 degree and is drawn counterclockwise. However, by specifying a different start angle, we can rotate the chart to improve its appearance or readability. In this code, the start angle is set to 90 degree, which means that the first segment begins from the top of the chart instead of the default position. The rest of the pie chart is then drawn relative to this new starting point. This feature is useful when you want to align the chart in a more visually appealing or meaningful way. Explode. This example shows how to highlight a specific portion of a pie chart using the explode parameter in matplotlib. The explode parameter is used to slightly separate one or more wedges from the center of the pie chart, making them stand out visually. It is defined as an array where each value corresponds to a wedge and the value indicates how far that wedge should be pulled away from the center. In this case, only the apple's slice is given a value of 0.2, so it is moved slightly outward while the other slices remain in place. This technique is useful for emphasizing important categories in the data and making the chart more visually engaging. Shadow. This example shows how to enhance a pie chart by adding a shadow and using a legend in matplotlib. The shadow parameter is set to true in the pie function, which adds a shadow effect behind the chart, making it look more visually appealing. The explode parameter is also used here to slightly separate a specific wedge, helping it stand out. Additionally, a legend can be added using the legend function to provide a clear explanation of each segment in the pie chart. If needed, a title can also be added to the legend to give it a proper heading. These features improve both the appearance and clarity of visualization. Colors. This code demonstrates how to customize the colors of each wedge in a pie chart using matplotlib. First, the data values and corresponding labels are defined. Then, a separate list called My Colors is created where each color corresponds to a specific wedge in the chart. The colors can be defined using color names, short codes like B for blue, or even hexadecimal color codes. The plt.py function is then used with the color parameter to apply these custom colors to each segment. This helps in making the chart more visually appealing and easier to distinguish between different categories. Finally, plt.show is used to display the pie chart. Creating scatter plots. This code demonstrates how to create a simple scatter plot using matplotlib. First, the required libraries are imported and the x and y values are defined using NumPy arrays. The plt.scatter function is then used to plot individual data points where each pair of x and y values represent a point on the graph. Unlike line plots, the points are not connected, which makes scatter plots ideal for observing relationships, patterns, or clusters in the data. Finally, plt.show is used to display the plot. Compare plots. This code demonstrates how to plot two scatter plots on the same figure using matplotlib. First, the data for the first dataset representing the age and speed of cars day 1 is defined and plotted using plt.scatter function. Then a second set of data for day 2 is defined and another plt.scatter call is used to plot these points on the same graph. Since both plots are drawn before calling plt.show, they appear together in a single figure. This allows easy comparison between two data sets, helping to identify patterns or differences in the data. Colors. This code demonstrates how to assign different colors to each point in a scatter plot using matplotlib. First, the x and y values are defined to represent the data points. Then, a separate array called colors is created where each element specifies the color for the corresponding point in the plot. The plt.scatter function is used with the parameter C set to this color array, which applies individual colors to each marker. This makes the plot more visually informative and helps in distinguishing between different data points easily. Finally, plt.show is used to display the scatter plot. Color map. This slide explains the concept of color maps in matplotlib, which are used to assign colors based on numerical values. A color map is essentially a range of colors where each color corresponds to a specific value, typically within a defined range like 0 to 100. For example, the VIRIDIS color map starts with dark purple for lower values and gradually changes to yellow for high values. This helps in visually representing variations in data more effectively. The color map can be applied using the CMap parameter in plotting functions. To use this, we also provide a set of numerical values where each value determines the color of corresponding data point. This technique is especially useful in scatter plots to represent an additional dimension of color of data through the color. Create a color array and specify a color map in scatter plot. This example demonstrates how to use a color map in a scatter plot to represent data using colors. First, the x and y values are defined and an additional array called colors is created where each value corresponds to a color intensity. The plt.scatter function is used with parameter C set to this array and CMap is set to viridis, which maps the values to a gradient of colors. This allows each data point to be displayed with a different color based on its value. In the second part, plt.colorbar is added, which displays a color scale beside the plot, helping to interpret what each color represents. This technique is useful when you want to visualize an extra dimension of data using color. This code demonstrates how to create a scatter plot using randomly generated data with different colors and sizes. First, NumPy is used to generate random values for x and y coordinates, each containing 100 points. Additional arrays are created for colors and sizes, where each value determines the color intensity and size of the corresponding point. The plt.scatter function is then used with parameters like C for colors, S for size, and alpha to control transparency. The CMap parameter is set to NIPY_spectral, which applies a colorful gradient to represent the values. The color bar is added using plt.colorbar to show the mapping between values and colors. Finally, plt.show displays the scatter plot, resulting in a visually rich representation of random data. Seaborn library. Seaborn is a Python library used mainly for creating statistical visualizations in a simple and visually appealing way. It is built on top of Matplotlib, which means it uses Matplotlib's functionality but provides better default size, styles, color palettes, and themes. This makes the plot look more attractive and easier to understand without requiring much customization. Seaborn is especially useful for visualizing complex datasets and relationships, making it a popular choice for data analysis and exploratory data visualization. Seaborn features. It is designed to make statistical data visualization simple and effective by providing built-in functions for common plots such as scatter plots, line plots, and histograms. It also offers predefined themes and styles which allow users to quickly enhance the visual appearance of their plots without much effort. Another important advantage is its seamless integration with pandas and NumPy, which means data from data frames and arrays can be used directly for visualization. This makes the overall process of data analysis and plotting more efficient, reducing the amount of code required while producing clean and professional looking graphs. Seaborn provides advanced visualization tools like facet grid and pair plots to analyze data more effectively. Facet grid is used to create multiple subplots based on categories which help in comparing data across different groups. Pair plots, on the other hand, display relationships between all pairs of numerical variables in a dataset, making it easier to identify patterns and correlations. Although Seaborn offers a high-level interface for quick plotting, it is built on top of Matplotlib, so it still allows detailed customization when needed. At the same time, its simple and intuitive API makes it easy to learn and use even for beginners with clear documentation and examples to guide users. Seaborn provides several common used plot types that help in analyzing and understanding data effectively. A scatter plot is used to show the relationship between two variables, while a line plot helps to visualize trends over time. Histograms are used for understanding how data is distributed, and box plots provide a summary of the distribution, including spread and outliers. Line plots offer a more detailed view of the data distribution by combining features of box plot and density plots. Heat maps are used to visualize correlations between variables in a matrix form, making patterns easier to identify. Pair plots, on the other hand, display relationships between multiple variables at once, helping to explore correlations and patterns in a dataset. These plots make data analysis more intuitive and visually clear. A scatter plot is used to visualize the relationship between two continuous variables by representing each data point as a dot on the graph. The position of each point is determined by its value on the x-axis and y-axis, making it easy to observe patterns, trends, or correlations between the variables. It also helps in identifying clusters or outliers in the data. The appearance of the plot can be customized using different colors and markers to distinguish between groups. In Seaborn, scatter plots are created using the scatter plot function, which provides a simple and effective way to generate visually appealing scatter plots. This code demonstrates how to create a scatter plot using Seaborn with category-based coloring. First, sample data is defined and converted into a pandas data frame. The scatterplot function from the Seaborn is then used to plot the data, where x and y represents the variables to be displayed on the axis. The hue parameter is used to differentiate categories, assigning different colors to points based on the values in the hue column, which helps in distinguishing groups visually. After plotting, a title and axis labels are added using matplotlib functions to make the graph more informative. Finally, the plot is displayed using plt.show. Line plots in Seaborn are used to visualize trends or patterns in data over time or across continuous variables. In a line plot, individual data points are connected by lines, making it easier to observe how values change smoothly. The SNS.lineplot function is used to create these plots. In the first example, the data is loaded and using Seaborn built-in dataset, and a simple line plot is created using time point and signal values. In the second example, additional customization is applied where the hue parameter is used to separate different categories, style is used to vary line appearance, and markers are added for better visibility of data points. Labels and a title are also included to make the plot more informative. Overall, line plots are very useful for analyzing trends and comparing multiple groups over time. Bar plots in Seaborn are used to show the relationship between a categorical variable and a continuous variable. Each bar represents a summary value, such as the mean or average for each category. The SNS.barplot function is used to create these plots. In this example, data is loaded from the Titanic dataset and a bar plot is created to show how the fare varies across different passenger classes. In the second example, additional customization is applied using the hue parameter to compare values based on another category such as gender. Other options like palette are used to improve the visual appearance, and labels and titles are added to make the plot more informative. This type of plot is useful for comparing values across different groups clearly. Seaborn histograms are used to visualize the distribution of a continuous variable by grouping data into bins and showing how many values fall into each bin. The SNS.histplot function is used to create these histograms easily. In the example, the iris dataset is loaded and a histogram is created for the petal length variable to understand how the values are distributed. In the customized version, additional parameters like bins are used to control the number of intervals, and KD equal to true adds a smooth curve to represent the data distribution more clearly. Colors, labels, and titles are also added to improve the appearance and readability of the plot. This type of visualization is useful for identifying patterns such as skewness or spread in the data. A box plot is a useful way to visualize important features of numerical data in a simple and compact form. It shows the median, which is the middle value of the dataset, giving an idea of the central tendency. In addition, it displays the range and quartiles, which help in understanding how the data is spread. The box represents the interquartile range, while lines extending from the box indicate the minimum and maximum values. This makes it easier to identify variations, spread, or even outliers in the data. Overall, a box plot provides a clear summary of the data distribution into quartiles. A box plot is also very useful for detecting outliers in a dataset. As it clearly shows the values that fall far outside the normal range, it also provides a compact summary of the data using a simple box and whisker structure, making it easy to compare distributions across different groups. The box plot is based on key statistical values such as quartiles, which divide the data into 4 parts. These include the first quartile 25%, the median or the second quartile 50%, and the third quartile 75%. Along with these, it also shows the minimum and maximum values of the dataset. Altogether, these 5 components give a clear picture of the data distribution, spread, and any unusual values. Demonstrates how to create a box plot using Seaborn to visualize the distribution of multiple datasets. First, the sample data is defined with 3 groups labeled A, B, C, and each containing numerical values. The SNS.boxplot function is then used to generate the box plot, where each column is treated as a separate dataset and displayed as an individual box. This allows easy comparison of median values, spread, and variation across the groups. The plot is further enhanced by adding a title and axis labels using matplotlib functions. Finally, plt.show is used to display the plot. This code demonstrates how to create a box plot in Seaborn that clearly highlights outliers in the dataset. First, sample data is defined where some values like 30 in column A and 28 in column B act as outliers. The data is then converted into a pandas data frame for easier handling. The SNS.boxplot function is used to create the plot where the parameter show means equal to true display the mean value along with the median, and whisk equal to 1.5 defines the range for detecting outliers. Any data point beyond this range are shown separately as outliers. Titles and labels are added to make the plot more informative, and finally plt.show is used to display the visualization. A violin plot in Seaborn is a type of visualization that combines features of both a box plot and a density plot. It not only shows summary statistics like the mean and interquartile range, but also displays the distribution of the data in a smooth and continuous form. The shape of the plot looks like a violin, where the width at different points represents how densely the data is distributed at those values. Wider sections indicate high concentration of the data, while narrower sections show fewer data points. Inside the violin, a line represents the median and a box-like structure shows the spread of the data. This makes violin plots very useful for understanding both the distribution and summary of the data in a single window. A heat map in Seaborn is used to represent data values using colors in a two-dimensional format. It is especially useful for visualizing relationships or correlations between variables in a dataset. In this example, the dataset is first loaded and the correlation between variables is calculated using cor function. Then SNS.heatmap is used to display these correlations values such as colors, where different colors represent different strengths of relationships. This makes it easy to quickly identify patterns such as strong or weak correlations between variables. Finally, plt.show is used to display the heat map. Pairs plots in Seaborn are used to visualize relationships between multiple variables in a dataset in a matrix format. Each plot in the matrix shows a scatter plot between a pair of variables, helping to identify patterns, trends, or correlations. The diagonal plots represent the distribution of each individual variable, usually in the form of histograms or density plots. In the example, a dataset is created and converted into a pandas data frame, and SNS.pair plot is used to generate the visualization. This type of plot is very useful for exploratory data analysis as it provides a complete overview of how variables are related to each other. This code demonstrates how to create a customized pair plot using Seaborn with the iris dataset. First, the dataset is loaded using sns.load underscore dataset, which contains measurements of different flower species. The sns.pairplot function is then used to create to visualize relationships between all pairs of numerical variables. The hue parameter is set to species, which means data points are colored based on the type of flower, making it easier to distinguish between categories. The diag underscore kind parameter is set to KDE, so the diagonal plot shows smooth density curves instead of histograms. The palette parameter is used to apply a visually appealing color scheme. Finally, a title is added and the plot is displayed using plt.show. A joint plot in Seaborn is used to combine two types of visualizations into a single view, typically a scatter plot and histograms. The central scatter plot shows relationships between two variables, helping to identify patterns or correlations. At the same time, the histograms on the top and side display the distribution of each variable individually. This gives a more complete understanding of the data by showing both the relationship and distribution together. In the example, sns.joinPlot function is used with kind set to scatter to create this combined visualization. Finally, plt.show is used to display this plot. Phase grid in Seaborn is used to create multiple plots based on categories in the data, making it easier to compare patterns across different groups. It organizes the plots into a grid layout where each subplot represents a subset of the data based on a categorical variable. In this example, the tips dataset is loaded and a phase grid is created based on the day column, which means separate plots are generated for each day. The map function is then used to apply a histogram of the total bill variable to each subplot. This helps in comparing how the distribution of total bills varies across different days. Overall, facet grid is very useful for analyzing grouped data in a structured and visually clear way. Demonstrates how to create a flexible grid layout of subplots using gridspec in matplotlib. The gridspec function is used to divide the figure into a grid of 2 rows and 3 columns with parameters like wspace and headspace controlling the spacing between the plots. Then plt.subplot is used with gridspec indexing to place plots in specific positions within the grid such as single cell, multiple cell or spanning multiple rows. The plt.grid true function is applied to each subplot to display grid lines, improving readability. This approach provides more control over subplot arrangement compared to the basic subplot method and is useful for creating complex and customized layouts. This This code demonstrates how to create a grid of subplots using subplots function in Matplotlib. The plt.subplot3,4 function creates a figure with 3 rows and 4 columns, resulting in a total of 12 subplots arranged in a grid. The fig size parameter is used to control the overall size of the figure, making the plots more readable. The returned figure object represents the entire canvas, while axis contains all the individual subplot areas. The figure.subtitle function is used to add a column title for entire grid of plots, which helps in providing a clear context for all the subplots together. Used to visualize data in 3 dimensions, allowing us to represent the relationships across 3 variables at the same time. This helps in identifying patterns, trends, or structures that may not be clearly visible in 2D plots. Although Seaborn itself does not directly support 3D plotting, it can be combined with Matplotlib's 3D capabilities to create such visualizations. By plotting data across the X, Y, and Z axis, we can gain deeper insights into complex data sets. These plots are especially useful in advanced data analysis and scientific applications. Seaborn can be used along with Matplotlib to create different types of 3D visualizations for better data understanding. A 3D scatter plot is used to show the relationship between 3 numerical variables, where each point is placed in a 3-dimensional line. Line plots in 3D are useful for showing trends or movement over time, especially when tracking changes across 3 variables. Surface plots are used to represent functions of 2 variables as a continuous surface in 3D, making it easier to observe patterns like peaks and valleys. These types of plots help in exploring complex data more effectively than standard 2D visualizations. This code represents how to create a 3D scatter plot using Matplotlib. First, sample data for X, Y, and Z axis are defined, representing 3 variables. A 3D plotting environment is created using fig.add_subplot with projection set to 3D. The ax.scatter function is then used to plot the points in 3-dimensional space, where C controls the color and S controls the size of the marker. Labels for all the 3 axes are added using set_x label, set_y label, and set_z label to clearly identify each dimension. A title is also added to describe the plot. The view_int function is used to adjust the viewing angle of the 3D plot, making it easier to visualize the data. Finally, grid lines are enabled for better readability, and plt.show displays the plot. This code demonstrates how to create a 3D line plot using Matplotlib. First, the data for X, Y, and Z axis is defined, representing points in 3-dimensional space. A figure is created using plot.figure, and a 3D axis is initialized using plot.axis with a projection set to 3D. The plot 3D function is then used to draw a line connecting the given points in 3D space, which helps in visualizing trends or paths across 3 variables. A title layout function is used to adjust spacing for better representation. A title is added to describe the plot, and finally, plot.show is used to display the 3D visualization. This code demonstrates how to create a 3D surface plot using Matplotlib. First, NumPy is used to generate evenly spaced values for X and Y using line space, and MeshGrid is used to create a 2D grid of points. A mathematical function is then defined to compute Z values based on X and Y, which determines the height of the surface at each point. A 3D plotting area is created using fig.add_subplot with projection set to 3D. The plot_surface function is used to generate the surface, and the CMap parameter applies a color gradient to represent different height values. Axis labels and a title are added for clarity, and the view angle is adjusted using view_init to improve visualization. Finally, plt.show displays the 3D surface plots. Seaborn is mainly used for visualizing numerical data, but it can also be creatively applied to represent text data when combined with Matplotlib. By using Seaborn's plotting features along with text-related functions from Matplotlib, we can create meaningful visualizations that include textual information. For example, word clouds can be used to display the frequency of words in a dataset, making more important terms stand out visually. Text annotations can be added to highlight specific points or provide explanations within a plot. Additionally, text-based charts can be created where labels and textual elements play a key role in conveying information. This approach helps in presenting the data in a more visual and engaging way. demonstrates how to create a word cloud to visualize text data. First, the required libraries are imported, including the word cloud library for generating the word cloud and matplot for displaying it. A sample text is defined which will be analyzed to determine the frequency of each word. The word cloud object is then created with settings like width, height, and background color. Using the generate function, the word cloud is created based on the given text where frequently occurring words appear larger in size. The plt.imshow function is used to display the word cloud as an image, and plt.axis_off removes the axis for a clearer look. Finally, plt.show displays the visualization. This code demonstrates how to add text annotations to a scatter plot using Seaborn and Matplotlib. First, sample data for x and y values is defined and a scatter plot is created using SNS.scatterplot. Then a loop is used to go through each data point, and the plt.text function is used to display the coordinates of each point directly on the graph. The parameters HA and VA are used to adjust the alignment of the text so that it appears clearer near each point. This makes the plot more informative by showing exact values along with the visual representations. Finally, plt.show is used to display the plot element. This code demonstrates how to use text as a visual element inside a plot using Matplotlib. First, a figure and axis are created using plt.subplots. Then ax.text function is used to place text directly within the plot area. The coordinates 0.5, 0.5 specify the position of the text, and the transform parameter is set to ax.transaxis, which means the position is defined relative to the axis from 0 to 1, placing the text at the center. The horizontal alignment and vertical alignment parameters ensure that the text is properly centered at that location. Finally, plt.show is used to display the plot. This method is useful for adding titles, notes, or highlighting important information directly within a visualization. Unit 3, thank you.